Hey guys! So today you and I are going to talk about code complexity. So let's get into it. So the question in question was, hi Frederick, how do you control code complexity as your application grows? Well, I try to do the thing that I call writing modular code, and the basics of that is that I try to segment out things into logical components, and then I group all the associated files that I have with those logical components or within those folders. And so the way you can think about it a little bit is that the classic, in my opinion, at the very least, sort of the indicator as to whether or not a person understands things like MVC or domain-driven design or these sorts of things. It's actually seen not necessarily in the abstractions that they create with different classes or functions and stuff like that, but more where they actually, like how they structure their source code. So an example would be if I go to a project and I see that there is a model folder, a view folder, and a controller folder, which is usually the classics. I know that they have failed to understand, at least what I argue, uh, how to modularize the thing that they are doing. So to put this in plain text, in plain speech, one of the things that, for example, I very much disagree with, which is, say, in the Java ecosystem and also in the .NET ecosystem quite a lot, is that you have the separation between the source code and the test. You usually separate those. And if you look at how, say, the Node.js community does it, or like the TypeScript and JavaScript communities and so forth, what they usually will do if you have a test runner, like it's not always the case because this mistakes happens there as well, but one of the things that you get, for example, with the Jest test runner out of the box is that you have a pattern match that actually looks for a underscore underscore test folder, and that can be anywhere. And so the practice that I have been using, for example, is that I always associate the tests with whatever I'm testing, like in the same folder. In other words, the thing that I refer to is that I'm centralizing all the files that are necessary in order to execute the functionality within that module. And the reason why I want to do that is because I want to achieve a state where everything I need to know about a specific area, like let's say the user model, or like it doesn't matter if it's front end or back end, the same technique applies. It's this idea of encapsulations that for maybe a few of you have heard about, for the object-oriented people around you. Like the encapsulation is not necessarily happening at the object level or the class level, it is happening at the directory level. In other words, the files themselves are encapsulated within the same module. And this is how you classically publish packages and things like that. It's just that for a lot of people, I think that that is not so obvious because I never see it by default for a lot of software developers. As I said, they usually have this, they structure their own code differently from that of, you know, a Maven package or like a NuGet package or an npm package, doesn't really matter what it is, right? And that, I believe, is the biggest fix that you can do in order to have your code manage complexity over time. The reason why I say that is because one of my favorite observations is that quite a lot of people have this idea of segmentation of concerns or separation of concerns. And one of the funniest things to me is when I see people opt in for things such as microservices or Kubernetes or stuff like that. And the reason they're doing this is that they want to separate their business logic into logical components. And so what I argue to them is that, well, you can do that at the source level. If you did the thing I just said, then you have achieved the separation that you would achieve with microservices. But you haven't bought into all the consequences of having microservices, because there's quite a lot of overhead, orchestration, model sharing, like there's tons and tons and tons of things that you get on top of, you know, the separation that comes with, say, microservices. So what I usually tell people is that if you don't know how to logically separate your different modules and components in a monolithic application, then you're not ready for microservices. Because what I argue is that all you're really doing is that you are you're basically moving the fact that you write spaghetti code, which is what I see usually when you have these like non-modularized separations of concerns. That's usually how it starts. Like you basically are spreading, as I said, you're spreading the knowledge. If you want to know everything about a user within the system, you have 3, 4, 5 different folders that you need to keep in sync in order to achieve that state, and that causes a lot of confusions. Whereas if you have things centralized in the same directory, you are more likely to have an understanding of where the boundaries for that package is. And as I like to say, if you wanted to split a monolith into microservices, you can do that if you do this, because literally the user module folder or whatever, where the user is, everything that you need to know in order to move that out into a, like, I mean, if you have the controller and the model and like everything like in that folder, you literally just have to copy paste that folder into another repository, and and spin it up with a separate server, and there you go. You now have a new microservice that we can go into when that is appropriate to do and so forth. But like, I hope you see what I'm saying. Like, there is no difference between doing this thing in a monolithic application and microservices, apart from the obvious things with having multiple servers and stuff like that. And so you achieve this control without the consequences of having multiple services. And that is the thing that at least I try to preach, because the thing, I will quote one of my coworkers. He said it better than I've ever heard anybody say it before. He said that in large distributed systems, it is much, much more efficient to structure the code and the source code management as a bazaar or a marketplace, where you have different stalls in some square somewhere, than it is to structure it as a cathedral. Because when you do this, which is very common, as I said, like developers think in terms of like that their entire project is just one giant construct. The problem with that thinking is that when you build a cathedral, everything has to fit into that bigger structure, and that is almost impossible when you continue to change things, different people are working on it and so forth. It requires a lot of skill and a lot of time and adjustments, and like everything just basically has to be perfect for that cathedral to work as one single unit. But if you structure things as a marketplace, then the only thing you really have to achieve is a basic structure where, okay, you have some folders and you can just keep on adding folders. It doesn't matter, because even if you have code that isn't used or so forth, you can just throw that thing away. A marketplace is a much more organic structure where you have new stall owners, or you have new people coming and going all the time. You have all the things you need in order for it to basically become its own living entity. And you trade basically perfect symmetry, perfect unity between all of these different things for a looser structure that can scale basically indefinitely. So what I want you to take away from this is that the way that I manage code complexity over time is that I try to write disposable code, and I try to modularize it as much as humanly possible. A good example of me doing this in recent time was when I had a team that had 38 repositories for a single application. Like for a very small application, it was a basic CRUD application. And the reason they had so many repositories was because what they had done basically was that they created different microservices for different entities. Like the classic one is they had users, they had entries, dictionaries, like all these different entities. So basically they did domain-driven design, but they put everything in whatever domain they had in a separate repository, which, as you can imagine, meant that they needed to synchronize 38 pipelines, synchronize the testing, and like whenever they wanted to do anything across the stack, which of course they couldn't do that because it becomes impractical to sync all of that, all of those repositories manually. And so they failed at that, so the quality actually went down. So what I told them was, all right, let's do this. We'll create a single monorepo, and we're going to take all of these Docker containerized microservices that you have. We're going to move them all into the same, like, one single source folder. They're still going to be in their separate folder. Basically, there's no difference between this. It's literally just moving those folders as is into a single source folder, so there are just a list of different modules. Then we will drop out the Docker container and the separate server, and you will expose the controller functions, this was a backend system, from each of these modules, and you will hook that in to a single server instance. In this case, it was a .NET application. In other words, you just import all of the controllers from each module. So now you have a monolith, but it uses the kernel pattern. And you should take a look at that. The kernel pattern is basically as you have a single kernel and multiple modules that you can latch on. And if you if you isolate your controller and all the associated services and business logic and models and so forth into a user folder, product folder, order folder, so forth and so forth, then the only thing that you need to expose from that folder in order to hook it into the monolithic application is the controller. That's all you have to do in essence, or a service or something like that. And all of a sudden you have achieved basically the same separation of concerns that you would have with microservices, but you don't have to take the hit of having so many different repositories and pipelines and so forth and so forth. And when you're running things in production and so forth, you don't have to do a lot of orchestration and so forth. And then you can of course separate that out into a new service again if a specific module needs to do that. But if you do it this way, what happens is that you can add folders and remove folders, you can duplicate things by mistake, because these things are realities, guys. Like pretending like you're gonna, as I said, my coworker's analogy with the cathedral, to pretend that you're gonna build this cathedral and then it's just gonna stay pristine, because like the thing with the real cathedral is that it's a lot of work to build it, but you build it once and then you don't keep on changing it. But that's how software works. So you need a mindset and a source code architecture that fits that dynamic ecosystem where you have multiple peoples, multiple teams, ownership change, scope changes, etc., etc. You need a structure that can deal with that you keep on changing and adding and removing stuff all the time without that becoming a single gigantic blob of mess, basically. And the way that I try to argue for it is to say that if you have the structure of a bazaar mindset, then each change becomes a linear increase in complexity. But if you have everything as a one single structure and everything just has to fit together, then every time you change something or add a new configuration or a new permutation, it becomes an exponential increase in complexity. So in this situation, if you just keep it modularized, at the very least, adding complexity in one of those folders and creating a shitty solution in that folder doesn't cascade to the rest of the system. Have a great day.